Transmission of nerve impulse is the next part of our lesson. The sum total of electrochemical changes that occurs in a neuron at the time of transmission of a stimulus is called an impulse. Neurons are excitable cells surrounded by extracellular fluid. Their membrane is selectively permeable to different ions. In the resting state, that is, when the neuron is not conducting any impulse, it is in polarized state. At this time, the interior of axon is more electronegative as compared to the extracellular fluid, which is electropositive. That means when a neuron is not conducting any impulse, the neuron is said to be polarized. That means inside the neuron it is electronegative and outside the neuron it is electropositive. The positivity of neuron is due to the presence of large number of sodium and potassium ions in the extracellular fluid. The major cations are potassium ions and sodium ions. On application of a stimulus, the membrane becomes freely permeable to cause the rapid influx of sodium ions. That is, when the neuron receives a stimulus, the permeability of the membrane changes. As a result, sodium ions moves in a very rapid manner into the axon. This action reverses the polarity at the site, that is, the inner side becomes positively charged and the ECF, extracellular fluid, becomes electronegative. This condition is called as depolarization. Earlier, the nerve cell is said to be polarized when ECF is positively charged and inside the axon it is negatively charged. Now it is called depolarized. What is the meaning of that? Depolarized means outside it is negatively charged and inside of the axon it is positively charged. Why this happened? Because the sodium ions have moved in. Why the sodium ions have moved in? Because the permeability of the neural membrane has changed. Why the neural membrane permeability has changed? Because it has just received a stimulus. The change of polarity results in potential difference and generation of action potential. The value of action potential is 30 millivolts to plus 60 millivolt. On depolarization and polarization, there is a development of electric poles, there is development of an electric circuit, there is the development of action potential due to potential difference, and this action potential is nothing but the impulse. As a result of local circuit is formed and the current flows from dendron to axon. In the same manner, sequential local circuits are formed all along the length of the axon and the impulse is conducted all along the length of the nerve fiber. Change in the polarity from depolarized back to the original state is called as repolarization. The polarized neuron will undergo depolarization. The depolarized neuron will regain its actual structure, and that is called as a repolarization. Change in polarity. Initially it is polarized, then changes the polarity into depolarization, then again changes the polarity into repolarization. The repolarization occurs after a short interval called as refractive period. The stimulus induced permeability to sodium ions is short-lived. Once the impulse is conducted, the membrane is repolarized and the fiber becomes responsive to further stimulation once again. The repolarization occurs after a short interval that is called as a refractive period. The stimulus induced permeability to sodium ions is short lived, and this is called as refractive period of the nerve fiber. The process of producing a wave of stimulation, depolarization, repolarization is repeated continuously at the axon terminal. In a medullated nerve, the insulating fatty myelin sheath prevents the flow of ions between axoplasm and ECF. The flow of ion operates only in the region of nodes of Ranvier. The action potential cannot travel as the wave of membrane depolarization it has to jump from one node to another. This process is called as saltatory conduction. The rate of saltatory conduction is 120 meter per second. It is 120 meter per second. (120 meter per second). Okay. The faster the continuous, it is faster than the continuous conduction in a non-myelinated fiber. Conduction of nerve impulse. We can see that in a diagram. A stimulus is applied. We have the repolarized state. We have the axon cylinder. It goes like that. Conduction of nerve impulse. Here is another diagram. Thank you.